Greetings out there on the internet. Today, I wanted to introduce you to the practice and idea of lattice notation, which is a way of conceptualizing and notating notes and harmonic spaces, a way of helping us conceptualize notes and how they interact harmonically speaking. Now, this is something that's utilized most often with just intonation, which is sort of the mama of the way we tune, which is known as equal temperament. However, there is no doubt a crossover and carryover of lattice notation into equal temperament that can help us make sense of harmony and how we navigate through music. And so let's get started. And we're going to start with, of course, the center of the known sonic universe, C. Gotta love us some C, right? So this magic dot is going to represent C, right? And all its octaves, right? So we can call it C. We can also, conceptually think of it as the one, right? It's oscillating 1 to 1, right? If I had superhuman powers and I could snap my fingers again in a 1-to-1 ratio exceedingly fast, I would get something like this. I get a one sound would be, and the other would be matching it, right? Now, quick aside, what is an octave? This is extremely important. Can you define for me what an octave is? Because a lot of people are going to be like, oh, well, that's 8 away. You just take 8 little stepping stones away, and you're going to be in octave land. You're not wrong. You're not wrong. But, well, hang on. Aren't there actually 12 notes? So, isn't it actually a 13th, right? Isn't it an octave really a 13th? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Maybe, I don't, but no, right? No, yes, maybe, could be, why not? Well, look, an octave is actually a doubling of the original waveform, a doubling in frequency of the original waveform. For instance, here's our wave, our first wave, and then check it out, I'm gonna double it. Oh, I'm doubling that shit. Okay, there it is. And now I'm gonna quadruple it. Woo! Okay, beautiful, right? The point being, look, an octave is actually a doubling of the original frequency. So if I go up the piano in C's, what we could say is actually happening is I've got 1 moving twice as fast, 4 times as fast, 8 times as fast, 16 times as fast, 32 times as fast, right? So I hope this is, sort of elucidating slowly that music is much more of a, it's more multiplicative than additive in its nature, okay? It is more multiplicative in its nature rather than additive and subtractive. And is it divisory? It is more divisory than subtractive, I suppose. So, okay, let's end that aside. An octave has less to do with 8, 1, 2, 3, 4, 5, 6, 7, 8, than it does with 2, power of 2. Okay, so this magical dot in the center also represents 2 to 1, 4 to 1, 8 to 1, etc. Right? Anyway, let's move on now. So, we've got our center of the universe, our 1. Beautiful. The next question is, what would be the next most logical the next most logical harmonic step after our 1 and its unison and its octave, right? Well, we can just go to the next prime number, which would be dun 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 3 up in this bitch, okay? So 1 times 2 times 3. And what do we get? We are in 5th land, right? Lo and behold, G has arisen from the overtonal series of C. Beautiful, right? If you had a string and it was a C string and you divided it perfectly in half, you would get another C. And then you divided it into thirds, perfect thirds. You divided it into a third, you'd get, lo and behold, G existing within the series, within the belly of C is G. And that would be 3, right? It's 3 times 1, but let's bring that within 1 octave. 3 times 2, okay? So important. When I ask, you know, like what's the next harmonic step after the octave? It's not D or D flat. No, 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 no. Harmonically, this is a big step. C to D. C to D flat, rather. Right? Yeah, and C to D, it's a bigger step. But C to G, notice how it sits, right? You sing a G. Forgive me. There it is, G. It sits very comfortably. It lasts. It doesn't want to move. It feels good, warm. It holds you, it hugs you. Okay? Because it's the next. Gosh, it comes right out of the existence of this. Right? Now let's keep going. Okay? So 1 times 2 times 3. Beautiful. Okay? Oh, and forgive me, but 3 against 2, right? So remember, this is 1 against 1. This is also 2 against 1. Right? So if I did that exceedingly fast, I would get something like. Now if I did this, 3 against 2, well, how about 3 against 1? 1, 2, 3, 1, 2, 3. If I did that exceedingly fast, I would get something like that, right? But if I did 3 against 2 exceedingly fast, I would get something like this. Right, now lo and behold, the silliness of that. What is commonly known as the perfect fifth is in fact a tripling of the original frequency. So what we've come to call the fifth has a lot more to do with 3 than it does with 5 steps. I mean, it sort of evolved into this 5-step thing because of how we tune and how we hear, but on the physical level of oscillations of the waveform, this frequency is being tripled. 1 times 2 times 3, 3 to 1, 3 to 2, beautiful. Moving on. So what would be the next most logical step from here? Well, we can approach the next prime number, right? So we had 1, 2, 3, 4 would be another C, right? 1, 2, 2, 3, 4, 5. The next prime number, la 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 la, and we'll give it a dot there. Go in another direction on this. It's a map, a lattice. It's also a map, right? And that, my friends, is known in musical parlance as E. Oh, so beautiful. And in terms of numbers, that's a quintupling of the original frequency, right? So I've got 1 down here, got 5 up here. That's 5 against 1, right? 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. This would be 5 against 2. And then lo and behold, our good old major third, 5 against 4. Now it is exceedingly important to cognize that the tuning on the piano is a bastardization of this ratio of 5 to 4. It is a rounded off tuning. We call it equal temperament. It is lovely. It allows us to do all sorts of amazing things. Namely change keys and play chromatically in all sorts of funky ways and modulate, whatever. So this CDE is actually it's not pure. It's a little bit dirty, all right? It ain't the real deal, but it definitely is an approximation of this real deal, this 5 to 4, which I wish I could show you right now. I'm not equipped to show you at this very moment, but I will show you in future videos, or you could Google just major third, a justly intonated major third. Now notice again another flip here in the common parlance, right? So octaves have more to do with 2, the power of 2, than they do with 8. Perfect fifths have more to do with the number 3, a tripling of the frequency, than they do with 5. And major thirds have more to do with a quintupling of the frequency than they do with 3 steps. So even though it's 3 steps, it's a quintupling of the original frequency. And lo and behold, you put all these together, and what do you get? You get a C chord, a magical triad. Beautiful. Now, we've just begun moving in one direction. Notice all these notes are emerging out of C. If I had a C string, right? If I had a C string right, and I divided it perfectly in half, I'd get a C, right? If I divided it into a third, I would get a G, right? And if I divided it into fifths, I'd get an E. So you can try this on your, I guess on your guitar or any stringed instrument you have. Divide it perfectly in half, you'll get an octave. Divide it perfectly to find that third, or that, I believe it's the second harmonic or the third partial. Find that division into three, you'll get the perfect fifth. You'll get the 3 to 2. Find where you divide into fourth, you'll get another C, right, in fourths, right? And then, lo and behold, the 5 against 4, E, right? Go up and down your strings on whatever stringed instrument you have, find these harmonics. Okay, now let's keep going, though. And now we're going the other direction, okay? We're going to go this way. We're going to ask, what is our center of the universe an overtone of, right? If I had a C string, and I divided it and divided it and divided it into perfect ratios and went up all the overtones of a C string, there are some notes that would never really show up authentically. They would never really show up. You might get close, but they would never show up. But there are other notes where immediately C will show up as an overtone. Any idea what they are? Well, let's start with our magic lines. Ba-ba-bum, ba-ba-bum. Let's get some magic dots. Ba-ba-bum, ba-ba-bum. And let's take this number and flip it over. It's a reciprocal, right? So I'm going to double that 2. I'm going to get 4, 3, okay? Now, to make this sort of simple to conceptualize, right? We know that G is the fifth of C, or G is the 3 to 2 of C. Right, so C would be the 3 to 2 of what? Or rather, C would be the fifth of bum, ba, ba, bum, F, okay? Right? The first reciprocal tone that shows up. The first tone showing up on our map that isn't of an overtonal origin, right? If you had a C string and went up through the overtones, you're not going to find F. But if you have an F string and you go up through the overtones, you're going to find C immediately, okay? Now, this is a fundamental flip in relationship, right? For instance, dig. If I play C, G, F, this is a common cadence that likes to resolve to. Right now I've got that, but let's make it that. Isn't that nice? One more time. Suspended 4 chord, resolving to the major triad. We build a little bit of tension when we straddle the tonic like this, and it's like a rubber band sort of expanding, and it wants to collapse into the center, and overtonal notes sound good to us. They generally sit a little easier like this, okay? Now, one more thing to do. We got to flip this over, right? We got to ask, okay, E is the major third of C, fantastic. C is the major third of what? Dun, 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 dun. What's the answer to that? Do we know? I'm going to tell you, it's A flat what? Okay, it's A flat, right? C is the major third of A flat. So if I had an A flat string and I found its perfect spot to divide it into fifths, I would get a C, okay? Now dig this. Oh, and let's take that ratio, right? 5 against 4, flip it over. 8 against 5. Now notice that's a more complex ratio, and hence the sound of C against A flat is more complex to the ear. It's more quote-unquote dissonant. There's more information. Your ear has to do a little more work to hear this than, say, 3 against 2, or 5 against 4 even, or 4 against 3, or certainly 2 against 1. Right, so these layers of complexity, I mean, simple, still pretty damn simple. Simple, but something more going on. It's your first division problem. Like, obviously, division, I would argue, definitely. Division is more complicated than multiplication, right? But this is the simplest division problem in our harmonic lattice, our simplest reciprocal, okay? So notice C and F, yeah. It's enigmatic to me. It's a nice sound, but it's the softest dissonance there is. 5 to 4. Okay. Now dig this 8 to 5. 8 to 5, very dramatic, right? Also known as the flat 6, right? Okay. Now dig it. Make a little triangle here, and what do we got? We got another triad. We got F minor over here, we got C major over here, our first overtonal chord and our first reciprocal chord, okay? Now these are 5 notes, they make 2 triads, okay? Let's just hear those triads. C major, I'm on C major here. F minor. C major. F minor. Again. Okay. Now, notice there is a, as we build this lattice out, we'll find that this movement towards New York, towards the Northeast, has a certain quality, a certain feeling, and the Southwest territory has a certain quality, a certain feeling, right? This keeps building and building and building, right? So here's our start. Let's take a look at expanding this a bit further. So what we can do from here is ask, okay, well, we've got our spine of fifths, so let's keep going here. Boom. Now we know that G is the fifth of C, so we can infer, okay, this must be the fifth of G, and lo and behold, it is D. Now, as far as figuring out the ratio, right, remember this was a tripling, or excuse me, this was a tripling of this. So this must be a tripling of this. So the ratio is 9 to 8. If you want to talk about how to do the math, a quick example, 3 over 2 times 3 over 1 gets you 9 over 2, but that's a wide gap, right? That's this. Here's our 2. Here's our 9, approximately, right? Here's 4 against 9, and 8 against 9. So within 1 octave, okay? Now notice, now we have our first melodic step expressed harmonically, right? C to D is a melodic step, 1, 2, as I think most of us are used to, but through the lattice we see that D is in fact 2 harmonic steps away, 2 fifths away, or as my teacher said, 2 pas away, right? Sa re ga ma pa, sa re ga ma pa, sa re ga ma pa, right? Okay. So dig that sound, 9 against 8, or the approximation thereof, right? C, G, D, or, right? So notice, well, we keep building. Let's keep building here. We'll keep building off the E, right? Ba 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 boom. We'll go up a fifth. We know a fifth, or you know, we should know the fifth of E is B, right? Here's B. Fantastic. Make that, oh, look at that, some abstract art. Let's make that a B, and let's, how are we going to figure out the ratio, right? It's the same thing we did here, right? 5 over 4 times 3, that's going to give us 15 to 2 to 4 to 8. So there's our B, also known as our major 7, which is oscillating at a ratio of 15 to 8 with the tonic, right? With our center of the universe. And lo and behold, we add our D, we add our B, and we get some new triads showing up, right? Here we've got E minor, here we've got G major, right? Now let's try going let's come this way, right? Sure. Another spine of fifths, a spine of fifths built off the major third, okay? We know that B is the fifth of E, so the question is E is the fifth of A, right? It is also the major third of F. And notice that gives us 2 more triads. Here we've got F major, here we got A minor, oops, right? Some more triads popping up. Now, as far as figuring out the ratio of this A, right? There's a few ways we can do it. We can take 5 to 4, and remember, if we're moving this way, we're doing the reciprocal of multiplying by 3. This way, we are multiplying the ratio by 3. This way, we are dividing the ratio by 3, okay? Now, and if we're moving north and south, right? Moving north, you are multiplying the ratio by 5. Moving south, you are dividing the ratio by 5. Okay, now, in all honesty, I am pretty, math is not my forte, right? I do like having an awareness of the numbers at play and the subjective listening states they evoke in my listening, but, it depends on the kind of musician you are. Some people are really, really into the numbers and really, really into, I don't know, they're just better at it. And it's not my strength, but I do think it's very important to be aware, especially of these fundamentals I mentioned earlier, like, an octave is a doubling of the frequency, a fifth is a major third is a quintupling of the frequency, a fifth is a tripling of the frequency, vice versa. Okay? A major second is a 9 to 8 relationship, right? Can you imagine doing a 9 to 8 polyrhythm in both your hands? Someone called Jacob Collier, right? Okay. Now, let's dig this A, right? How are we going to figure out what this ratio is? I'm going to go ahead and tell you, I'm going to go ahead and tell you that this ratio is a 5 to 3 ratio, right? Here's our bastardized tuning of it in equal temperament. Okay. Now, how do we get to that, right? Well, let's look. So 4 to 3. Here's our F, right? 4 to 3, 4 over 3. We'll do some, some basic fraction multiplication. 4 to 3 times 5, right? Times 5. That gives us 20 over 3. Now remember, 20 is a power of 2, so we can reduce it. We want this to be within 1 octave, right? So let's see, how can I reduce this? Well, 20 divided by 4 is what? 5, right? 20 divided by 4 gives me 5. 5 over 3. There's our major sixth within an octave, okay? I hope that made sense. If not, ask some questions. I'll try and clarify what I can as best I can. Now, another way to figure this out, right, would be to come from the 5 to 4 and divide, right? So 5 over 4 divided by 3, okay? And I believe, when you're doing fraction division, right, you multiply like this, right? So that's going to give us 5 times 1 is 5, 3 times 4, 12. Now, we got to reduce this. How do we reduce this? Divide by 4 to get it within 1 octave. That gives you 12 divided by 4 is 3. Lo and behold, another 5 over 3. Okay? Now, look, if this isn't terribly clear, don't worry. Honestly, the conceptualization of the numbers, like I said, is not so important. I think it's just important to know that these harmonic relationships can be represented numerically, and it will give you a deeper insight into understanding harmony as opposed to just thinking intervallically, because there's a difference. There's an important distinction between thinking. It's like, as I mentioned earlier, when you're thinking intervallically, you're thinking in terms of addition and subtraction. But of course, there's a little more complexity when you're thinking in terms of in a multiplicative, or what's the word, divisory? It's not a word, but if you're thinking in terms of multiplication and division, you get a more holistic view on what is going on when we're dealing with harmony. It isn't as simple as 1, 2, 3, 4, 5, 6. We can actually see that an A is derived by going up to the major third, and then the reciprocal of the major third coming down, right? Up to the major third, reciprocal, right? Or to the fourth, and that gives me an F major triad. Can go another way. Okay. Let's keep going. Now, this is an interesting note, the sixth, because it's both overtonal, right? It's derived overtonally, but it exists reciprocally as well, right? So it's got more going on with it than a purely overtonal note, right? Or a purely reciprocal note. It has a bit of both worlds in there. and it gives it, that just gives it what it gives it. It just gives it a certain quality, right? Let's see if we can round all this out. Maybe we'll come down one more. So if we come down one more, right, we're getting the reciprocal fifth of A, fancy way of saying the fourth of A, and that would be D, okay? Right, and lo and behold, that gives us a D minor triad. Now I'm just going to go ahead and tell you that this ratio is 10 to 9. Forgive me, I do not feel like doing the math right now because I am bad at it. But anyway, this is an important moment because notice we have a D over here. We have a D over here. These Ds are of a different nature. This D is derived completely through overtonal relationships, right? The fifth of the tonic. Whereas this D is derived, you could say it's the sixth of the fourth of the tonic, or rather it's derived through reciprocal processes, through a reciprocal process, an overtonal process, and another reciprocal process, or a reciprocal process and a reciprocal process and an overtonal process, giving us two notes that, were we in true just intonation, would sound very close together. But on the keyboard, what's nice about the D on the keyboard is it can stand for both of these subjective musical experiences of a 9 to 8 and a 10 to 9. I would imagine some people would disagree with that, but I got to stay true to my listening and to my teachers, and that's the miracle of equal temperament, is this D can be multiple Ds. It can even, as you know, maybe you don't know, but it can also be E double flat. It can be C double sharp, which is even a more different musical experience. Okay, a lot of information going on here. I hope it's opening some doors for you or helping you imagine some new possibilities in terms of harmony. Okay, let's keep on going, right? Because this just keeps going. So dig, let's keep coming down. We'll get the reciprocal fifth of F, okay? And notice that gives us another triad, right? What triad? B flat major shows up here, okay? Boom, B flat, D, F, right? And dig this, the same way that we had this reciprocal is just the flipping over of this, right? 3 over 2, turn that 2 into a 4, 4 over 3, right? Same thing here. Take this 9 to 8, flip it over, we get 16 to 9, okay? And there's our B flat. Notice this is expanding. Chords are coming in, and we got more rows to go because, okay, let's fill out this row until we have a more complete picture here, right? So now we'll come on down here into reciprocal territory. A flat, we're going to ask, okay, what is the fifth of A flat? Why don't we, reciprocal territory, overtonal direction. Reciprocal territory, overtonal direction. The fifth of A flat is dun 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 dun, E flat. Beautiful note. Notice E flat. G is the major third of E flat. Dun 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 dun. Notice this gives us two triads. Triangle for triad. A flat major. And C minor all of a sudden. Okay, so we rolling. We making our progress. We are sort of filling out the map as we go, okay? Now, as far as figuring out, okay, what is the harmonic ratio of this E flat? I'm just going to go ahead and tell you. 6 to 5, okay? And now notice, I hope this is also clarifying, what is dissonance, okay? I don't know if dissonance is really too useful of a term. That's just a way of saying a more complex relationship, okay? And a complex relationship, like for instance, 15 to 8, can be made excruciatingly sweet by adding in some bridges of connection, right? Right, so I'm adding the E and G there to connect, and lo and behold, that gives us a C major 7, right? What if I add this? I got C, G, D, and B flat. I'll go. right? That B sounds so sweet now because of the bridge I built to get there. Sounds sweet to me. But if you just jump from a 1 to 1 to a 15 to 8, it can be a little grating on the ear. I mean, I can still dig it. Why not? But you see what I'm saying? So we can lead ourselves to more complex states of harmony, and they just sound so lovely, so rich. But of course, we got to know how to traverse the topography of harmony to get there in an eloquent and sensible way, instead of just guessing. Although I do like guessing, or rather making informed guesses based on practice, right? You practice this stuff, you know where you are, what you're doing, and then when you want to improvise, you improvise and forget about knowing, just go for it and find some things, discover some things. Okay, let's keep going. So now we're going to do the reciprocal fifth of A flat, which would be what? It would be D flat. D flat. Wonderful. Notice, oh, beautiful, that gives us a major third. F is the major third of D flat. Okay, now if we're going to figure out the ratio of good old D to the flat, we got boom, ba-boom, 16, 15. Forgive me for not doing the math. I would probably just make a mistake, honestly. Okay, now things are expanding. Oh, lo and behold, also that D flat gave us a minor, B flat minor. Okay, look at all these cool shapes, some pentagons and octagons and etc. Ooh, an octagon, right? 1, 2, 3, 4, 5. No, it's a hexagon. Some hexagonal goodness going on here. Let's round it out up here. We're going to go up a fifth from E flat, and that's going to give us another B flat. Now this gives us another enigmatic moment because we got a B flat over here. Just the same way we have D and D, B flat and B. Two different kinds of dominant sevens, right? A dominant seven that's more overtonally oriented and a dominant seven that's more reciprocally oriented, right? And I would state that in the confines of equal temperament, you can evoke this kind of B flat as well as this kind of B flat and have a different harmonic experience going on when you do it, baby. Okay. Da, 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 da. This gives us two new triads. We've got, what do we got? E flat major. We got G minor. Fantastic. Oh my gosh, let's figure out this ratio. How would we do it, right? We go 6 over 5. We multiply by 3. We get 6, 12, 18 over 5. Let's reduce this, right? 4. Nope. 2, 9. 9 to 5. Boom. This, B flat. 9, 2, 5. There we go. That's my 5. I love 5. Okay. Now, lo and behold, this is sort of the beginning of the map, right? Because remember, it keeps going. It goes up further and keep going and keep going. And here's our triads, right? We got C major. We got E minor. We got G major. We got C minor. We got E flat. We got G minor. We got A flat. We got F minor. We got F major. We got A minor. We got D minor. We got B flat. We got B flat minor. We got D flat. Now there's some chords and a map to help you get around here, right? So here's going to be my one-handed improvisation while I point to move around, right? Dig it. C. I'll go in triads to F, to B flat, all right? To B flat minor, why not? D flat, F minor, C minor, A flat, C minor, one more time A flat, C minor, E flat, C major, G, C, F, B flat, D minor, A minor, C. Okay, so take a look at this and try moving around through it and knowing where you are, okay? Know where you are and try and build some of your own, right? Now notice this we've got a lot of symbols on the page. We got the numbers, we got the notes, and we got the triads, right? In my next video, I'm going to show you how to do this on staff paper, which is kind of more to my liking. I'm not too good with numbers, honestly, but I am good with other things, like going like this. Okay, so to each their own, right? Everyone's got their strengths. Anyway, I hope this was insightful. Thanks for taking the time to check it out. Please drop any questions or comments below, criticism, etc. But I want to help you understand harmony in a deeper way, and I want to help you understand music in a deeper way. Keep on rocking. Peace.